Hello everyone, welcome back to this channel. This video is part of a series that aims to explore different concepts within VHDL. This video in particular takes a look at sequential statements and processes and the different part of processes, the difference between concurrent statements and processes, as well as the different types of sequential statements that can be found within processes. In our last video, we talked about the different types of architectural styles, and you can view that video by taking a look at the playlist on the channel. So without further ado, let's get started. In the previous videos, we explored concurrent statements and the different architectural styles within VHDL. Most programming languages are used to implement functionalities in a sequential manner, one instruction at a time. VHDL, however, describes hardware, and therefore instructions are implemented concurrently. In our video where we described the different concurrent statements, we mentioned processes. Processes are a type of concurrent statements that contain within it sequential statements. If you viewed our last video, processes or process statements are an essential part of a behavioral modeling type of architecture, where it itself is a concurrent statement that contains sequential statements within it. It is identified by four main parts. We have the label, we have the sensitivity list, and we have the declaration area, and the body, which is in the begin to end area. In the slide in front of you is an example of a process statement. We've highlighted the different parts we mentioned in different colors corresponding to the different sections within this process or within the code. Let's look at the first part of the process, which is its label. The label is optional but should always be included as a good coding practice to promote the self-description of your VHDL code. The next part of the process is the sensitivity list. Now, what is a sensitivity list? To understand sensitivity lists, let's talk about concurrent signal assignment statements again. In concurrent statements, anytime there is a change in the signals listed on the right-hand side of the signal operator, the signal on the left-hand side is re-evaluated. However, that's not the case for behavioral architectural styles that use processes, and that's not the same for processes, because the processes sensitivity lists is a list of signals that would trigger the process to be re-evaluated anytime a change occurs to those signals. So the evaluation of the process statement is controlled by the signals found in the sensitivity list of that process. But what if the process does not have any signals in its sensitivity list? What would happen in that case? In that case, the process will execute continuously. To further solidify this point of sensitivity lists, let's take a look at two ways we can model an XOR. One with the data flow style of architecture, and the other with the behavioral style of architecture. These two modelings are effectively the same, except the syntax is significantly different. Not only that, the time they execute is different too. Even though both of the architectures have the same signal assignment statement of XOR_out being A XOR B, the execution of the statement in the data flow architecture happens anytime there's a change in signal A or B. Whereas within the process in the behavioral style architecture, this is executed anytime there are any changes in the signal in the process sensitivity list. Now that we've understood processes and their sensitivity lists, we also have the third part of the process, which is the declaration part, and this is useful to declare any variables that would be needed within the process sequential statements. And finally, the fourth part of the process is the interesting part, and it's the body. We will talk about the different types of sequential statements that can be used within the body in the next few slides. So, what are the different types of sequential statements that we can define or put within the body of the process? We have the signal assignment statement, which is very similar to the concurrent signal assignment because of the signal assignment operator. Then we have the if statements and the case statement. So let's observe the first statement, which is the signal assignment statement. This statement is the same as the one that is used in the concurrent statement, but it is in the sequential paradigm. The only difference is that if this signal assignment appears within a process, it will execute sequentially upon any change within the sensitivity list. When we look back at our example of XOR, when it was in the data flow style architecture as a concurrent statement, it was executed every time a change appeared in the signal A or B. However, within the sequential statement, it is executed every time there is a change within the process sensitivity list. And in this case, the process sensitivity list includes signals A and B. Let's look at the second type of sequential statements, the if statement. You should be familiar with this statement if you have been coding for a while. The if statement depends on the conditions listed in the body of the statement. The general form of the if statement is shown in the slide. We can see that if a condition is true, then a statement would execute. If you had other options or other conditions that you would like to check for and execute a different statement for, you would add else if there were many other conditions, or else if you only had one more condition to evaluate. The final clause or the final else clause is optional, but not including the final else clause sometimes causes a possibility that none of the sequence of statements associated with the if statement will be evaluated. So it would be a good coding practice to include an else statement. Also, if statements in VHDL is functionally similar to the VHDL concurrent statement, the conditional signal assignment statement, and is considered the sequential equivalent of the conditional signal assignment statement. To further realize the use of if statements, let's try to design a 4-to-1 multiplexer with the help of if statements. To do that, of course, we need to write the entity of the mux 4-to-1, where we have a clock signal, a select signal that is an STD logic vector of 2 bits, 1 down to 0, and we have 4 inputs and 1 output. To design the behavior of a 4-to-1 multiplexer using a process, we need to first create a process label, and in this case, we've named the label mux 4-to-1, and this, as you remember, is optional, but it is considered good coding practice to have it. And the process is dependent on the clock, so it has a sensitivity to the changes of the clock. Now, you could, of course, leave the sensitivity list empty, but this would mean that the process will execute continuously. Then, as you would do with any if statement, we will first evaluate the different options of the select, and according to the select values, we will route the correct data to the output. So if the select is 0, 0, then data 0 is routed to the output. If it's 0, 1, data 1 is routed to the output. If it's 1, 0, data 2 is routed to the output. And if it's 1, 1, data 3 is routed to the output. If none of the cases are satisfied, the 0 is routed to the output. Notice how the last else was not needed, but was kept there because it's considered good coding practice. Finally, the last sequential statement that we'll be taking a look at is the case statement. The case statement functions similarly to the if statement but is a bit different. Let's look at the syntax of the case statement. We can see that the syntax is case expression is. When choice, we have a certain sequential statement. When it's another choice, we have another sequential statement. And finally, we end it with when others, where we would route a different sequential statement to the case where it is others. Then we end the case statement. Just like the if statement is the equivalent or the sequential equivalent of the conditional signal assignment, the case statement is the sequential equivalent of the VHDL concurrent selected signal assignment statement. Kindly note that the when others line is not required but should be used as a good programming practice. To bring the idea of case statements home, let's design the same 41 multiplexer with the help of case statements. To do that, we first need to write the process. And we will include the clock as a signal of the sensitivity list in this case, where each change in the clock input would result in the process to be re-evaluated. Then we could use the select or the cell signal as the expression to be evaluated within the case statement. When the cell is in the case 0, 0, data 0 is routed to the output. When it's 0, 1, data 1 is routed to the output. When it's 1, 0, data 2 is routed to the output. And when it's 1, 1, data 3 is routed to the output. If none of the cases are satisfied, the when others is executed and 0 is routed to the output, just as shown. Thank you so much for watching this video, and I hope you found it useful. If you do find this channel useful, consider subscribing or supporting me on my Patreon page, where you can find the notes behind this tutorial on my Patreon page. Thank you for watching, and see you in the next one.